Hello, hello, hello. Good morning. Welcome to Math for Thursday, December 17th, the last YouTube live lesson of 2020. The next time I see you here on the YouTubes, it will be 2021. It will be a brand new year with so much more to cover in this wonderful world of mathematics. Today, we're getting our introduction to algebra on the coordinate plane. Here's the things you're going to need. Something to write on, something to write with. If you've got graph paper and a ruler to make yourself a coordinate plane, that'd be great. If you don't, remember there is a virtual whiteboard or virtual graph paper on a virtual whiteboard. The link to that is on our virtual classroom. So many things virtual. I miss, high-fiving people. That's neither here nor there. And our I can today down there says, I can create ordered pairs and plot them on a coordinate plane based on an expression with a variable. That was a lot. Before we get to all that, but first, that's my line. I was going to say that, and rude. Anyway, but first a warm-up. Take a look at, I'm going to go this way. Take a look at this pattern here, these two sets. We have column A, column B. And think about, what do you notice about the relationship between our A data and our B data? What do you notice? What do you see? Think about how our A data is moving. Think about how our B data is moving. And then look across. Look at what could become our ordered pairs. What do we notice about the relationship between our A and our B? Thinking about 1 and 3, 2 and 6, 3 and 9, 4 and 12, 5 and 15. One thing I'm noticing, and I see that in the chat as well, column B goes by threes. Goes up by 3 every time. 0 plus 3, 3 plus 3, 6 plus 3, 9 plus 3, so on and so forth. A goes up by 1. 0 plus 1, 1 plus 1, 2 plus 1, 3 plus 1. Okay? And then the relationship between the two, right? How do we get from 1 to 3? How do we get from 2 to 6? Well, 1 plus 2 is 3. 2 plus 4 is 6. 3 plus 6 is 9. That's not really, that's kind of consistent, but I see in the chat it says every A, there are 3 B's. It's a nice way to put it. Are we saying that B is 3 times as much as A? So if we do 1 times 3, we get 3. 2 times 3 to get 6. 3 times 3 to get 9. Absolutely. So what we can say, if we were to write this as an equation, would be 3 times A, or 3A, equals B. Okay? Are there any other ways we could write this? What if we wanted A by itself? What's our inverse operation to multiplication? How do we get from 3 back down to 1? 6 back down to 2, right? Our inverse operation of multiplication is division. So we could do B divided by 3, right? 3 divided by 3 is 1. 6 divided by 3 is 2. Or another way of saying that is A equals 1/3 times B. Right? 1/3 of 3 is 1. If I take 3 and I break them into 3 pieces, if I take that 3 and I make 3 equal groups, there's 1 in each group. So 1 is 1/3 of 3. 2 is 1/3 of 6, or 1/3 as much, right? All kind of equivalent statements here. So all 3 of these are equations we could write to represent this data. And then we can graph it on the coordinate plane. We're going to try that. Not with this expression, though. We're going to start a little bit simpler. Okay? The first expression we're going to start with as we move to the digital whiteboard, there it is. Oh, look at it, it's so fancy. The first expression we're going to start with, and I'm going to do it in blue, because I do want us to take a look at a number of these expressions on the coordinate plane. The first one we're going to try, remember these are our, quickly, oh hold on, you know what? I'm jumping ahead. Let's go back to our in real life whiteboard here and just review our coordinate plane and our ordered pairs, right? For our ordered pairs, we have an x value and a y value, right? And then our x-axis is this one down here going across. So we always go across first. And then our y-axis, our y value, is plotted on sort of the up and down. So if we go back to this data set, we might want to change these actually from A and B to X and Y. So if X equals 0, Y would also equal 0, right at our origin, right? X equals 1, Y equals 3. So we would go over 1 on the x-axis, and then 3 on the y-axis, and right where they meet, there's our 1, 3. Okay, and then it would go from there. So let's take a look at maybe a slightly simpler equation on our digital whiteboard here. We're going to start simple. We're just going to go literally with, as I remind, this is our x, and this is our y over here. We're going to go with, in blue, we're going to go with x equals y. Okay? Then what we want to do is we want to think about, okay, if x equals 0, what does y equal? And I'll move my face to the bottom there, so you can see the x equals y in blue. And if we're thinking about, okay, x equals 0 in this equation, what would y equal? Right, we can substitute our x for 0. Oops, without that extra bit there. Now, what would y equal? Yeah, y would also equal 0, right? Because we don't have any operations to do. We're just saying, oh, this thing also equals this thing with x equals y. So we're going to go ahead and plot that. So we can put 0 and 0 right there, right at our origin. Then what number would come next in our order? Right? 1 and 1. So we made this a chart, 0 and 0, 1 and 1, 2 and 2, 3 and 3, and so on, right? And all we're doing is we're going to plot these on our coordinate plane. So 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, so on until the cows come home. And we can see there a pretty clear line in blue. And in fact, if we wanted to, we could take our ruler and draw that line all the way up. Okay, so there is our x equals y. And I'm actually going to write it right there next to the line. So every x value, every value on the x-axis, you're going to have the exact same value on the y-axis. Okay? Now, let's change something. Let's add an operation and see how that changes our line on the coordinate plane. What if we went with, as I erase our data here, what if we went with something more like, let's go, and we'll put this in red. What if we went with x plus 2 equals y? Let's try that. So let's start with, I always like to start with x equaling 0, just because it gives us a real good place to start there. As they say in, what is it, doe a deer, a female deer, let's start at the very beginning. It's a very good place to start. Okay? So if x equals 0, and we'll erase and replace, if x equals 0, what does y equal? Yeah, it equals 2. 0 plus 2 equals 2. So we end up with an ordered pair of 0 for the x and 2 for the y. And we can plot that. Go 0 on the x and then 1, 2 on the y to go right there. 0, 2. So what other ordered pairs might be there? You can't really make dots on the digital graph paper. Oh, shoot. That's a flaw in the system. We'll have to find a different digital graph paper. Apologies. So follow along with your eyes while you go. I'm sorry if the digital graph paper is not doing its job. What if x equaled 1? Let's say 1 plus 2 is 3. Okay, what if x equaled 2? Erase and replace. 2 plus 2 is 4. And it just goes up stepwise just like that. So we can plot those. 0 and 2. 1 and 3 goes there. 1 spot over, 3 spots up. 2 and 4, 2 spots over, 4 spots up. What would come next? Yeah, oh, we can already see that pattern there. Look at that. Going up, 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 up. If we take our ruler and we put it in a line, oops, get rid of there, and we can see there, this is x plus 2 equals y. What do you notice about these two lines? What do you notice about x equals y and then x plus 2 equals y, other than the blue line is thicker than the red line because I was using a different size pen? They almost look like they're traveling in the exact same direction, don't they? What's the name for those two lines that are going the exact same direction and will never touch, even if they go on infinitely? Do we remember? Drop it in the chat. First person to drop it in the chat gets, well, you get the pride in knowing that you knew the answer. While we do that, let's try something different. We're going to do this one in, let's do it in green, shall we? Green. Let's actually plot that one that we had up earlier. Let's do 3 times x equals y, because we've already got that data. So 3 times x equals y, or 3x equals y. Yes, it's parallel. We had 2 people in the chat say parallel. Yeah, those two lines are parallel. Or we can say they have the same slope. That's a word you'll hear later on in math, a little bit more of slope. Okay, let's check our 3 times x equals y and see how that goes. So if we revisit our data here, as I munch our coordinate plane. There we go. Ta-da! I'm sure it's real tiny in the corner, but behind me, we've got the first point of 0, 0, right? X equals 0, y equals 0, right? Because 3 times 0, anything times 0, is 0. So our green point and our blue point start at the exact same place. Okay, now let's look at the next point. X equals 1, y equals 3. So let's put that on our graph here. X equals 1 and y equals 3. Oh, we switched from the blue line to the red line. Interesting. I wonder if it'll like go back and forth between the blue and the red. It'll zigzag. Maybe. Let's check our next data point here. X equals 2, y equals 6. Let's see how this goes. X equals 2, y equals 6. Oh, hello. We've got a completely different thing going on here. Let's plot one more. X is 3, y is 9. So 3 over, and then 9 up. This is why I put in the little 5, 10, 15 markers. Whoa, look at that. I think we've got enough points to draw a line here, but it's definitely not that 45 degrees that we had before. It is much steeper. Let's see if we can get it there. Whoa. So here is our 3x equals y. What do we notice about this line? Way steeper, huh? Different slope, definitely not parallel to the red and the blue. How interesting. Let's do one more. And I'm curious about this one. I'm actually going to take us back to the full cam for this. What about this? What if we did something real wild here? Stay with me. What if we just switched our data? And instead of 3x equals y, now we have 3y equals x, or 1/3 x equals y. And let's do this one in pink. So this one's going to be 1/3 times x, or x divided by 3, equals y. So now, again, 0, 0. But this time, we're going to have y equal 1 and x equal 3. So let's go 3 over, 1 up. Then we're going to have y equal 2, x equals 6. So we'll have 6, 2 on our ordered pair. And then we'll have 9, 3 instead of 3, 9. Whoa. If we connect those together, oh, my line was slightly off. A lot shallower of a slope on that one. Interesting. Oh, shoot. I was doing that whole thing and you were just staring at my face. There it is. I forgot to change scenes. Sorry. So what we're looking at here is really being able to take an ordered pair or a set of ordered pairs and plot them out using our go across first, then go up, And what we're noticing here with these expressions is they kind of do follow a pattern. And if you have two sets of data, an x and a y, that are connected like this, you'll end up with a straight line. But depending on what you're doing, the line can change. Depending on the operation that you're doing, the line can change. Now, I love that this is new. It is new. And do I expect you to have mastery of this in one lesson? Absolutely not. This is just our intro today. Okay? We're going to get more practice on it on iReady when we're done with this. If you have questions or want extra practice with this, come to office hour. But I encourage you to go through the whole iReady lesson and do the quiz, because it's going to kind of reinforce this stuff and allow you a little bit more structured practice time. Because I know it's a lot from your teacher to just kind of throw it all to you on a YouTube lesson. But really, this is kind of the introduction and almost the like you watch and I do part. And now you're going to go try it on your own. Okay, everybody? Thank you for tuning in. If I don't see you out there in YouTube land, have a happy new year, and we will see you in 2021. All right? Take care. Happy math.